under a quiet sky. Imagine a single point of light, moving with careless patience. Not a flare or a satellite, not the hurried blink of a man-made thing, but an ancient traveler that had drifted alone for longer than any human story. For centuries it had known only cold and distance, the slow arithmetic of gravity and time. Then it brushed past our little system, and in doing so, handed us a question we had not yet learned to ask. They called it 3i Atlas. The name was practical, tidy, a label for a moment that would refuse tidy answers. It was catalogued by a vigilant network of telescopes whose daily work is to watch the familiar sky for the unfamiliar. At first, the numbers were unremarkable. The orbit fit the math. The velocity and path marked it as interstellar. Astronomers noted it, tallied the data, and placed it among the rare roster of visitors from beyond our stellar neighborhood. For some observers, it was an event, the way a distant ship on a horizon is an event. For others, it was an invitation. In the beginning, the object behaved like a comet. Under the right light, we could see a faint coma, a halo of gas and dust warmed into breath by the Sunday. Instruments recorded hydroxyl signatures, traces of water molecules cleaving under solar photons. Those are the familiar signatures we expect when ice heats and sighs in the inner system. The early spectral readings read like a familiar lullaby. We could, with some confidence, prepare charts and predictions and fill pages of technical logs. And yet, as more eyes turned, the lullaby altered its notes. First came the light curve. On a graph that usually smooths into the predictable rise and fall of brightness, 3i Atlas danced. It flared, dimmed, pulsed, then flared again. These were not the jittery blips of instrumental noise, nor the telltale wobbles you can explain away with a passing atmospheric disturbance. Observatories on different continents, separate instruments, independent teams recorded the same jagged sequence. When data converges like this, the result demands attention. Instruments that split light into its component colors revealed further anomalies. Normally, a comet reveals its chemistry in clean lines. Water, carbon compounds, sodium, a smattering of organic molecules. But 3i Atlas offered ratios that refused to fit models we have used for generations. Carbon dioxide dominated where water should have been abundant. Nickel appeared in odd purity while iron receded. In spectral regions we thought well-mapped, faint emission features shimmered that matched no element catalogued in human tables. Measurements like this can come from poor calibration, or from a transient process, or from something truly novel. The teams did their due diligence. Calibration, cross-checks, independent verifications. The anomalies persisted. At Harvard and at NASA centers, at observatories under southern skies and in orbital instruments, scientists began to speak in a mixture of wonder and caution. The community is careful by habit. Hypotheses are weighed in precise language. But in private conversations, in the long midnight threads that astronomers sometimes write to each other, the surprising words started to appear. Hidden in the measured ratios were hints that something about the object behaved with a regularity that looked intentional. Then the beam appeared, on an October night that would split the calendar into before and after for the people watching. A narrow, coherent feature emerged from the object's surface and reached across space like a fingertip of light. It was unlike sunlight glancing off dust. It had a geometry and steadiness that defied scatter. It held a tight profile, its brightness sustained across a distance where light usually diffuses into indistinguishable haze. Telescopes saw it angle itself with disconcerting precision toward Mars, aligning not roughly but with a mathematical neatness that made instrument teams pause their routines and call one another. Hard science demands caution. Every anomaly invites the simplest explanation first. Could this be an optical artifact, a reflection created by chance geometry between instrument, object, and observer? Could it be a transient plasma jet produced by sublimation under an unusual surface composition? Could a rotating, textured nucleus throw a narrow tongue of light in a way we have not seen? Teams examined raw frames, traced sensor chains, compared timestamps, and eliminated mundane explanations. The structure remained real within the bounds of the data. When this beam maintained its direction and intensity, the conversation changed. A beam that persists, that points, that can be traced with repeatable geometry across multiple observations implies a mechanism. In astrophysical terms, that mechanism could be a focused emission, a collimated jet produced by confined plasma, or a magnetic nozzle. In engineering terms, it could be a transmitter, a propulsion exhaust, or a directed energy device. The words we use shift with the hypotheses: jet, laser, beacon, engine. Each word carries a baggage of implication, and each demands a different kind of test. A beam that targets Mars is not simply an astronomical curiosity. Mars is a neighbor in the cosmic sense. Anything aimed in that direction could be observed by instruments that orbit that planet. The Mars Reconnaissance Orbiter, the mobile eyes and cameras perched at another world, offered a vantage point we could not ignore. For the first time, an interstellar object might be seen not only from Earth, but through the perspective of another planet. That prospect mobilized teams across space agencies. Telemetry was rearranged, observation schedules shuffled, and a focused campaign emerged. Scientific protocol here is also ritual, and the ritual can be urgent. What followed were days of patient watching. Instruments recorded further strange behavior. The object's color shifted with a speed that lacked precedent. At distances too cold for ordinary photochemical reactions, its coma bloomed green, as if carbon compounds were fluorescing in a way choreographed rather than accidental. But the timing of the color shifts matched other patterns too. Certain pulses of brightness aligned with phases in which Mars fell within the narrow cone described by the beam. The coincidences multiplied until coincidence itself could no longer carry weight. Astronomers called the object a chameleon, not as a metaphor alone, but because its observable properties appeared to change under a set of variables that suggested response. Response is a loaded word. It invokes the possibility of feedback, regulation, even control. A system that modulates its output with respect to external geometry is not just reacting to a gradient of solar heating. It is monitoring the geometry and altering its behavior according to some internal rule. Such behavior, in the absence of an obvious natural mechanism, invites questions about agency. No scientist worth the name moved directly to headlines announcing extraterrestrial intelligence. The threshold for that claim is enormous. Instead, the community adhered to a checklist that has built modern instrument science: rule out error, accumulate independent data, model every plausible natural mechanism, attempt replication and prediction. They published preliminary results. They convened telecons. They wrote email chains that filled servers with careful, precise skepticism. Yet, among the careful phrases, one could hear a quiet thread of excitement. If the object was not natural, then the implications would force a deep reordering of our assumptions. If it was natural, then a whole chapter of astrophysics needed rewriting to encompass the processes that could produce such features. Part of what made this so compelling was the object's materials story. Comets in our system are rich in water, ice, dust, silicates, and a complex brew of organics. They are fundamentally frozen remnants of the protoplanetary disks that birth planetary systems. Spectroscopy usually confirms this. with consistent signatures. 3i Atlas told a different tale. Water signatures were faint compared with expectations. Metal content, when inferred, appeared in unexpected proportions. Nickel presented with remarkable purity relative to iron. On Earth and in meteorites across the solar system, nickel follows iron as a duet. A separation on this scale hints at either an uncommon formation environment or an active process that separates elements with a kind of refinement. Refinement is an interesting word in this context. Nature refines too, in ways we do not always anticipate. Processes in high-temperature plasmas, fractionation in accretion environments, or unusual stellar nucleosynthesis can produce odd signatures. Yet human industry also refines, and the resulting ratios can mirror what we interpret as unnatural. The ambiguity between an exotic natural origin and a product of technology is a central knot of the story. If technology is the explanation, then the scales involved are staggering. Interstellar engineers would have to work on dimensions and timescales that dwarf human planning. Yet so would the engineers of nature. The distinction between intelligent design and extreme natural process is not purely semantic. It changes the explanatory framework we use. A machine implies intentions, constraints, and possibly messages. A natural object implies different histories and different physical laws in play. The empirical task remained the same: observe, model, question. The more the teams observed, the more questions unfurled. The object's tail, where dust and ion flows usually stream away from the sun, behaved contrary to textbook predictions. Normally, solar wind pressure scours and irons a comet's tail outward, sculpting it into a directional banner that points away. In certain geometries, an anti-tail can appear due to perspective, a faint illusion that tricks casual viewers. 3i Atlas presented a forward-piercing structure, a spear of light that seemed to push toward the star instead of being swept by it. Its coherence, its alignment with a planetary target, and its persistence suggested controlled directionality rather than a geometric mirage. When the word directionality takes root, the geometry of observation matters more than ever. Instruments that could measure polarization, phase angles, and coherent structure took center stage. Polarization states can betray organized light, and coherence functions can show phase relationships that make the difference between scattered sunlight and an emitted beam. The data again presented suggestive patterns. Certain observations showed polarization signatures that were inconsistent with random scattering and more consistent with a directed, organized emission process. Across the world, theorists composed models, both conservative and radical. Some extended cometary physics into new regimes where exotic ice phases, driven by microstructural geometry and trapped volatiles, could produce collimated jets. Those models are elegant and difficult. They require a rethinking of how surfaces fracture and how plasma interacts in the microgravity skin of a tiny body. Other theorists, including some who had been criticized in the past for their willingness to entertain non-natural origins of interstellar visitors, leaned into alternative frameworks. They considered artifacts, constructs, and probes engineered for persistence over galactic journeys. Whichever the hypothesis, the narrative changed the meaning we assign to our observations. To suppose a probe is to suppose intention transmitted across space and time. To suppose a natural object performing as it did is to suppose our models are incomplete in a profound way. Either answer forces humility, the chatter that spills beyond labs and into public forums, strained to keep a tone between caution and wonder. Public science communicators emphasized the need for peer review. Panel discussions balanced excitement and sobriety. When public figures spoke, their words had weight. Some scientists took measured stances, acknowledging anomalies while resisting sensational claims. Others, more poetic, embraced the notion that we were witnessing a threshold moment when the universe offered something that might point beyond itself. And then there were the ethical considerations. If a directed emission could be a message, what are the consequences of answering it? We have protocols around transmission, modest and cautious, born of decades of debate about active SETI. But a beam that arrives at our doorstep, whether aimed at a planet or not, complicates the question. Who speaks for Earth? Which instruments can record and not respond? The reflex to reply is ancient in our species, but so is the reflex to observe and listen. Many argued for maximal observation and maximal restraint. Through all of this, the narration maintained a human rhythm. Telescopes tracked, data streamed, hypotheses proliferated, and the community balanced between the technical work and the metaphysical implications. The science remained the backbone of dialogue, the common language in which the extraordinary could be translated into testable questions. Observations became experiments. Predictions were forged and sometimes falsified. A scientific method in motion is a patient, iterative art. There were nights when the story settled into quieter tones. In control rooms around the world, engineers brewed coffee and checked clocks. Scientists leaned back from monitors as images scrolled, sometimes laughing with relief at a solved calibration problem, sometimes falling silent at a frame that resisted simple classification. The longer this went on, the more the object seemed to play at the boundary between the known and the unknowable. The Mars window approached. The trajectory that had once seemed like a routine arc now carried the excitement of a rendezvous. Instruments aboard Martian orbiters were repurposed to take shots at a moving target that was itself a moving target. This was an observational ballet. The images that would arrive from Mars might not resolve every mystery, but they promised a fresh perspective. Observing from a different vantage point reduces parallax errors, offers alternate phase angles, and sometimes reveals features smeared out from Earth's line of sight. If anything could break ambiguity, it would be additional geometry. On the appointed day, the cameras on the Mars orbiter turned. The data ticks came across deep space with a patience that belied the breathless expectation on Earth. Frames arrived. Scientists passed them with both caution and hunger. The images showed a surface ragged with erosion and pockmarks, a nucleus dotted with irregularities, a coma that varied in density across its breadth, and in some frames the forward-pointing structure was visible with the crispness a different geometry allows. It had, in those moments, a mechanical clarity that tightened the circle of speculation. Even so, the images did not provide an answer so much as narrow the space of plausible explanations. They revealed surfaces and structures that could be interpreted as either unusual outgassing geometries or as components of a complex device. Scientists continued to update models. The work of parsing noise from signal continues in such cases for months, even years. Anomalies need time to yield their truths. Among the voices that followed the story, some cultural figures and philosophers wondered aloud about the existential implications. If an interstellar object could be engineered, if the galaxy contained artifacts built with intentions that could persist across time, then the human story would be a chapter in a much larger narrative. That possibility reshapes how we think about ourselves and our responsibilities. It is a humbling frame. It also introduces wonder. Others reminded audiences of the hard lessons of staying grounded in data. Extraordinary conclusions must rest on extraordinary evidence. The community of scientists put a premium on patience, and the public practiced a kind of eager patience in turn. There were debates about terminology, about whether to call the object a probe or a natural remnant. Words mattered because they shaped the frameworks in which we explore. As months lengthened, more data accumulated, models matured. Some anomalies were explained with refined cometary physics. Microstructures on the nucleus could act as nozzles in particular thermal conditions, producing narrow jets and sudden color changes under certain incidence angles. In other cases, the spectral oddities found alternative interpretations when reanalyzed with updated instrument characterizations. Science, in practice, is often incremental, pruning exotic branches as calibration and modeling fill in the blanks. Yet, not everything resolved. Certain emission lines resisted identification, and certain ratios remained stubbornly out of line with any neat, natural process. Those lingering anomalies sustained speculation and drove more observation. The object drifted on, its path carrying it back toward interstellar space. Its message, whatever it was, encoded in photons and angles and chemistries. If this narrative sounds like a mystery without a neat final chapter, that is because the cosmos often speaks in sentences that stretch beyond our lifespan. The story of 3I Atlas is a reminder that our knowledge is patchwork, an edifice built with tools we constantly improve. Some questions the universe offers require new tools to answer. We make those tools and we learn. There is also a quieter lesson that runs beneath the technicalities. In watching, measuring, and arguing over this visitor, humanity rehearsed something essential. We practiced patience in the face of the unknown. We learned how to translate astonishment into method. We practiced humility and also curiosity. Those are the twin muscles of scientific civilization. And still, at night, the image returns. Picture the lone point of light drifting beyond our vision. Picture Mars receding in the background, its cameras having offered new perspective and yet withheld certainty. Picture the beam reduced again to faint memory across astronomical distances. Imagine engineers and poets and coffee-stained observers alike stepping back from screens to look up with the rest of us. If 3I Atlas was an engineered artifact, then somewhere in the galaxy, a mind once set a mechanism in motion that would long outlive the mind that created it. If it was a strange product of nature, then the galaxy contains processes we do not yet know how to foresee. Either way, the object left us with the same gift. It forced us to listen. So, as you lay yourself down beneath ordinary stars, let this be your quiet meditation. The night sky is not simply a map of objects we have mastered. It is a ledger of mysteries that teach us about the humility we must carry as we grow our knowledge. Sometimes the universe gives us an easy lesson. Sometimes it hands us a riddle that will take generations of patient inquiry to resolve. Tonight, in the hush between breaths, imagine 3I Atlas continuing its endless drift. Imagine it as ice and rock and chemistry, operating on natural rules we have yet to fully know. Imagine it as a machine designed to cross the dark, carrying within its structure the quiet persistence of a craft built for time spans that make human lifetimes seem like the blink between frames of a long movie. Either way, the message glows in the space between thought and sleep. The cosmos is not altogether silent. It transmits in frequencies we can only sometimes decode. Sometimes it compels us to invent better ways to listen. We become participants in a universe that, whether by accident or design, keeps finding ways to touch us with its vast, patient light. Rest now. Let questions settle into the woodwork of your thoughts. Let wonder be a gentle companion to sleep. For tomorrow, telescopes will wake, instruments will recalibrate, theories will be rewritten or confirmed, and a human conversation will continue about whether a traveler from across the gulf carried an answer, a signal, or simply an elegant counterexample to what we thought we knew. If there is any comfort in all of this, It is the same as the comfort of a long, steady tide. The universe moves in patterns larger than fear, larger than headline cycles. And in those patterns we find space to learn. Good night.